An FTS5 index can look healthy while returning stale rows. External content triggers keep inserts, updates, and deletes synchronized, so Python search results match the source table. You'll see how to connect the pieces into a workflow that applies row rights and returns synchronized search matches. I'm Professor Pi, teaching search and IR with simple Python. Search backed by SQLite often feels straightforward, until results quietly drift. You write into a content table and expect the full text index to follow. In external content mode, FTS5 stores tokens separately and won't magically mirror your table. That mismatch can sneakily break analytics or an API that depends on accurate search hints. The goal is simple. When your Python inserts, updates, or deletes a row, the FTS5 index updates immediately. That keeps search correct without copying text into the FTS table itself. For small to medium datasets, this avoids duplication and keeps a single source of truth. At a glance, external content FTS5 points at your real table and reuses its rowids. The index keeps posting lists keyed by those rowids. If you insert a new row but never tell FTS5, the posting list won't include it and a match will miss the row. Triggers are the straightforward bridge that notify FTS5 as writes happen. We'll walk a compact example that starts broken, then backfills the index, then adds insert, update, and delete triggers, and finally uses an integrity check with a rebuild fallback. I'll point out why each step matters, so you don't ever return stale matches. Quick note: this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. The first step shows the minimal external content setup that can fail silently, so we can observe the bug. This snippet creates the smallest SQLite FTS5 external content setup that can fail silently. The content table docs has 2 rows, and docs FTS points at it with content docs and content rowid ID. The important catch is that writing to docs does not automatically populate the FTS5 index. db execute reads the real table count, then runs a match query against docs FTS for SQLite. The visible output shows source rows exist, but the search index returns no hits, which is exactly the stale or missing retrieval failure we need to eliminate. Now that we can see the index is empty, we need a way to make FTS5 build its index from existing content. This example uses SQLite's documented FTS5 rebuild command to backfill the missing index. Rebuild matters when the content table already has data before docs FTS or its triggers exist. The special insert into docs FTS tells FTS5 to discard the current index and recreate it from docs. After that, db.execute runs the same kind of match query, but now row ID and body come back from the external content table. The visible output shows the SQLite row is searchable, which gives us a clean baseline before adding live synchronization. Backfill fixes the past, but future writes still need to be synchronized. Next, we add an insert trigger, so new rows appear instantly. This code adds the first live synchronization path for SQLite writes. A rebuild fixes the past, but retrieval systems also need future inserts to appear without caller discipline in every write path. The docs AI trigger copies new.id and new.body into docs FTS whenever docs receives a new row. Then, the snippet inserts a new document about BM25 ranking and queries docs FTS with the FTS5 table-valued function syntax. The visible output shows the new row ID is immediately searchable, which removes one class of missing result bugs. With inserts handled, edits are the next gap. Updates must replace old tokens with new ones. This snippet handles the update case where relevance can quietly drift. If docs changes from hybrid notes to vector fusion notes, the old terms must leave the index and the new terms must enter it. The docs AU trigger first sends FTS5 the special delete command with old ID and old body, then inserts the new row text. That ordering is important because FTS5 needs the old token values to remove the previous postings correctly. The visible output shows hybrid no longer matches, and vector now does, which confirms edits are reflected in search behavior. Deletes are the final fragile case. A removed row must stop showing up in results. This example closes the loop for a small but complete SQLite synchronization baseline. Deletes are especially sensitive because a stale posting can keep returning a row that no longer exists or no longer has the expected text. The docs add trigger sends the FTS5 delete command with old ID and old body. Then the integrity check command with reg set to 1 asks SQLite to compare the external index with docs. If that check raises SQLite 3.database error, the code runs rebuild as a repair fallback. The visible output shows deleted text no longer matches and whether repair was needed. Mapping this tiny example into your project is straightforward. Apply the same trigger patterns to your articles or notes table and run the integrity check on a schedule. If your writes touch multiple tables inside a transaction, make sure triggers fire in an order that exposes the final committed values to the index. What you learned: why external content FTS5 can go stale, how to backfill with rebuild, and how insert update delete triggers keep the index synchronized. Use this when you want one canonical text table and a separate FTS index. Be mindful of transaction ordering and complex multi-table writes. Those are where subtle bugs hide. To extend this, measure integrity check frequency and rebuild cost on a realistic dataset, like your user articles or support tickets. Try running integrity check after heavy write batches, and tune timing so rebuilds are rare, but never leave stale postings. If practical IR that actually behaves in production helps you, subscribe and watch the IR videos.